welcome to Edupedia World Grade 10 Computer Science Video Lecture Series. I'm Upeka Vandibona, and from this episode we are going to talk about the errors in C++. In this episode, we are discussing the correctness of programs. That means about errors. Errors are simply unavoidable when you develop a program, yet the final program must be free of errors, or at least free of errors that we consider unacceptable for it. There are many ways of classifying errors, so here we listed down few of them. Compile time errors. These errors are found by the compiler. We can further classify compile time errors based on which language rules they violate. For example, syntax errors and type errors. The second one is link time errors. These are the errors found by the linker when it is trying to combine the objects files into an executable program. The third type, runtime errors. These are the errors found by checks in a running program. We can further classify runtime errors as errors detected by the computer, that means hardware or the operating system, errors detected by a library, for example the standard library, and errors detected by user code. The fourth type is logic errors. These are the errors found by the programmer looking for the cause of erroneous result. It is tempting to say that our job as programmers is to eliminate all errors. That is of course the ideal, but often that's not feasible. In fact, for real-world programs, it can be hard to know exactly what all errors means. If we kicked out the power code from your computer while it executed your program, would that be an error that you were supposed to handle? In many cases, the answer is obviously not. But what if we were talking about a medical monitoring program or the control program for a telephone switch? In those cases, a user could reasonably expect that something in the system of which your program was a part will do something sensible even if your computer lost power or a cosmic ray damaged the memory holding your program. The key question becomes, is my program supposed to detect that error? Unless we specifically say otherwise, we will assume that your program should produce the desired result for all legal inputs, should give reasonable error message for all illegal inputs, need not to worry about misbehaving hardware, need not to worry about misbehaving system software, is allowed to terminate after finding an error. However, the assumption 1 and 2 are included in the definition of basic professionalism, and professionalism is one of our goals. When we write programs, errors are natural and unavoidable. The question is, how do we deal with them? Our guess is that avoiding, finding and correcting errors takes 90% or more of the effort when developing serious software. For safety critical programs, the effort can be still greater. Anyway, you can do much better for small programs. Basically, we offer 3 approaches to producing acceptable software. Organize software to minimize errors, eliminate most of the errors we made through debugging and testing, and make sure the remaining errors are not serious. None of these approaches can completely eliminate errors by itself. Anyway, we have to use all 3. Experience matters immensely when it comes to producing reliable programs. Programs that can be relied on to do what they are supposed to do with an acceptable error rate. And please don't forget that the ideal is that our programs always do the right thing. Now I am going to talk about how errors are being born. The source, how it starts. Here are some sources of errors. The first one is the poor specification. We always have to be specific about what a program should do. We have to make sure that all cases are handled. For example, every input gives a correct answer or an adequate error message. The second one is incomplete programs. During development, there are obviously cases that we haven't yet taken care of. That's unavoidable, but anyway, we have to know when we have handled all cases. The third one is unexpected arguments. Functions take arguments. If a function is given an argument we don't handle, we have a problem. For example, calling the standard library square root function with a negative value as the argument. We cannot find the square root of a negative value. Check it out what this function would do. The fourth one is unexpected input. Programs typically read data from a keyboard, from files, from GUIs, from network connections, etc. A program makes many assumptions about such inputs, for example, whether the user will input a number or a string value. What if the user input a string value rather than the expected integer? If we do not handle that kind of situations correctly, possibly there would be an error. Now the fifth one is unexpected state. Actually the state here means about data. Most of the programs keep a lot of data around for use by different parts of the system. For example, address lists, phone directories, temperature readings, etc. What if such data is incomplete or wrong? The various parts of the program must still manage. The last one is logical errors. That means the code that simply doesn't do what it was supposed to do. We'll just have to find and fix such problems. Okay, now this list has a practical use. We can use it as a checklist when we are considering how far we have come with a program. No program is complete until we have considered all of these potential sources of errors. In fact, it is prudent to keep them in mind from the very start of the project. We will continue this discussion to the next episode to specifically talk about compile time errors. In here, we just give you the general idea about errors. So stay tuned on with Edupedia World and thank you for watching.